In this series of videos, I'm going to walk you through everything you need to know to learn the basics of Arduino. And so starting in this video, we're just going to talk about the very fundamentals of electricity to get an idea of what it is and how it works. So we're going to kind of take it back to the root of everything. These are the four fundamental forces of nature that are responsible for every action that happens anywhere in the universe. And so they're gravity, the strong nuclear force, the weak nuclear force, and electromagnetism, which is what we're interested in. But just kind of to give a brief overview of all of them, gravity is basically, that attractive force between two masses, right? So if I'm holding a pencil here, right, it falls down to the earth because the earth is pulling down on the pencil. But the pencil is also pulling up on the earth itself, but it has such a small mass that it's inconsequential. So then there's the strong nuclear force, which is the force responsible for holding together the nucleus. So the nucleus, right, is composed of protons and neutrons, so it's overall a net positive charge. And those positive charges want to get away from each other, but the strong nuclear force is responsible for holding them together. And then the weak nuclear force is the mechanism of interactions between subatomic particles, and it's basically responsible for radioactive decay. And then finally, what we're going to do is we're going to talk about electromagnetism, which is actually that force that I mentioned before. It's this interaction between charged particles. So previously, we kind of thought about electricity and magnetism as two different things, but they're actually like the manifestation of the same force known as electromagnetism. And so this force is the one that acts on electrically charged particles. So opposite charges attract and like charges repel. So two positive things are going to want to repel away from each other, but a positive and a negative thing is going to be attracted to each other. And the reason for that is everything in the universe wants to be like at a neutral, balanced, or like zero energy state. That's why things are falling, that's why the universe is expanding and why it's cooling, because it wants to reach this zero energy state. And so electromagnetism is responsible for a lot of things, but one of its core things is keeping the electrons orbiting the nucleus. And so I'm going to kind of show you some examples here of how electricity and magnetism are essentially governed by the same force. But we can think about electricity as when there is some presence of some net positive or net negative electric charge, there's an electric field that radiates out from it. And then when we move that charge, we actually get the presence of a magnetic field. So I'm going to show you some ways of kind of creating that on your own. And so these are kind of the tools you would need if you wanted to do this independently. You'll need like a large iron nail, some enameled copper wire, a battery or some form of power supply, a magnet, and then it's sometimes helpful to have something that will measure voltage, like a multimeter. So let's kind of switch over to my camera here, and what you can see is I have a battery, I have some alligator clips here, and then this is my iron nail that has an enameled copper wire. So this is something you would find in a part called a transformer, and so it is just copper wire, but it has a red enamel, a very thin layer of enamel to prevent it from coming in contact with itself. So I've actually scratched off the enamel here, so you can kind of barely just see that it's slightly more orange here, and that's the bare copper. So I've attached one end to this green, and I'm going to plug it onto one terminal of the batteries, and then the other one goes to this switch, which goes to my yellow alligator clip, and I'm going to connect that to the other end of the battery. And what we're going to see here is when I turn on this switch, by applying electricity to this system here, it's going to create a magnetic field, and it's going to attract and pick up these different things here. And so the reason why we're using this setup is by coiling the wire, it really amplifies the magnetic field, and by adding this iron piece in the middle as the core to this magnet, it further amplifies the magnetic field. So it'll have a stronger impact, and we'll be able to see it pick up some stuff here. Alright, so I'm going to go ahead and flip on this switch, and we can see it immediately starts picking it up, and I guess I should move my hand out of the way. There we go. So it starts picking up the iron nails, and it actually can pick up two of them, and then right when I switch it off here, they fall. And you can see now that my desk is very not level, my house is not level, but that's what we've got here. All right, so now let's do it one last time here, right? So it's not doing anything, and then when I flip it on, I can now pick it up, and then when I flip it off, it lets go. So this is, creating a magnet with electricity, something known as an electromagnet that is showing how electricity and magnetism are basically, part of the same force here. And so the reason I said to use like a rubber band is you can hold it around like the ends of a AA battery, because the system can get a little hot over time because it's, discharging a lot of electricity across this coil, so you'll want to kind of watch out for that. But now I'm going to show you how to use magnetism to create electricity. So let me move this system here out of the way. All right, so there's a couple of different ways of showing this here, but here I have kind of the same setup, the same enameled copper wire around the nail, hooked up to a multimeter, and as you can see right now, it's reading 0 volts. There we go, that's a little bit better. And then I have this pretty strong magnet here, and so when I move it, well, I guess I need to move my hand out of the way, right? So there, when I move it and hold it down, it's attracted to the iron nail, but as I move it nearby, you can kind of see that it starts to induce a voltage or some electric potential across this system here. And so we are producing electricity with a magnet. Another way to do that is by playing around with a motor. So right here I kind of have a typical what's called a DC motor. And so it has this part here, which is how we attach the wires to apply electricity to this motor. And what happens is you can see there's more enameled copper wire inside of here that is meant to amplify the magnetic field. And then inside of this case for the motor, you can see there's one magnet here and another magnet there. Those are 2 permanent magnets mounted inside of here. And so when you apply electricity to the motor, what happens is it creates opposing magnetic fields on each of these little plates here that repels away from this. And then as it rotates, it starts to change the polarity of the magnetic field, so it continues to rotate around. And there's a lot of good animations of that online, and we'll get to that a little bit later. But what I want to do is show how we can create electricity using magnetism. So this is a motor that basically takes electrical energy and turns it into mechanical energy. But by using mechanical energy, my hand spinning it, I can then create electricity due to the magnets inside of here. So I'm going to show that process here. So right here, I have another motor wired up to this LED right here. And so when I spin this with enough force, you can see it starts to light up here. And that's because my mechanical energy of spinning the rotor here of this motor is turning the coils inside of those permanent magnets mounted inside of this case. And that's creating electricity here on those wires. And that electricity is enough to then power that LED for a brief period of time as I'm spinning it. And so if we wanted to see that maybe a little bit more amplified and consistent, I have it connected up to this drill here, right? And so if I turn this on, we see that the LED here glows pretty consistently. So that's how basically we can create electricity from magnetism and magnetism from electricity, showing that these 2 things are different manifestations of the same force, electromagnetism. And this is just kind of some of those animations that I was talking about, and we're going to talk about how motors work in a little bit more detail. But yeah, basically the only difference between a motor and a generator is kind of how it's used. It's a lot of the same principles at play here. A motor is just using electrical energy and turning it into mechanical energy, and a generator is using mechanical energy and turning it into electrical energy. But both of those things are doing it through the magnetism of these coils and the permanent magnets mounted inside of the case. All right, so let's talk about electricity more specifically here, right? So you've probably done this before where you maybe like rubbed a balloon up against your hair or like a wool sweater, and you've seen static electricity in action, or you've been walking around the house and touched a door knob and felt that little jolt of electricity there. So what static electricity is this buildup of an imbalance in electric charges. And so we can kind of see on this simulation here, right? If I take a balloon and I rub it in close proximity here, some materials are better at it than others. But what happens is it's dislodging some of these electrons here, and so this balloon now has a net negative charge, and the sweater here has a net positive charge. So when I let go of it here, it gets attracted to that, and if I kind of let go of it over here, it will attach itself to the wall, and it actually starts to repel away some of the negative electrons there. And so that's what's happening with static electricity is atoms are rubbing together in close proximity, and some types of materials are better at dislodging electrons than others, and there's this built-up of this imbalance of charge. So when I'm walking around my house here and I have this buildup of electric charge, I have static electricity inside of me, and then when I go to touch the doorknob, that is actually not static electricity. That little arc that you can see, maybe if it's really dark, that is now current electricity or dynamic electricity, because there's no longer this buildup of this imbalance of charge. It's actually discharging it, because now there's this complete path for it to flow from a high energy state down to a low energy state. Right? So that is kind of this difference between what we call static electricity and current electricity or dynamic electricity. So again, static electricity, we can kind of think about it as like potential energy. So again, if I'm holding up this pencil, it has potential energy. It has the potential to fall for gravity to act on it. And then when I let go of it, it becomes kinetic energy, or the energy of movement. And so in electricity, we have static electricity and current electricity. So again, static electricity is that buildup of the imbalance of charges. And then current electricity is once there is now a path for that electricity to flow, and it can go down to that low energy state. And so energy is actually transmitted in current electricity, but in static electricity, no electricity is transmitted. And so that kind of brings us to the last point here, is the definition of a circuit. So this is the dictionary definition of a circuit, kind of, irrespective of thinking about electricity and stuff like that. It's just defined as a circular journey, or one beginning and ending at the same place. And so in electricity, a circuit is the same thing. It has to kind of go in a complete loop, and if that circuit is broken anywhere, it ceases to be a circuit, and no energy can flow, no electricity can flow. And so that's going to be important once we get to the point where we're actually building our own circuits. If we don't complete that path, if we don't complete that circuit, no electricity is going to flow. And so we need to make sure that there is no break anywhere in our circuit. Sometimes we can refer to that as an open circuit or a broken circuit, or else that electricity won't flow. So in the next video, we're going to talk about Ohm's law and kind of what governs how electricity flows and some of the different parameters involved in it.